Welcome to True Projects. In this video, we are going to explain about the project that is detecting unbalanced network traffic intrusions with deep learning. Before getting into the execution, first let us understand what is the project about. In today's world, pretty much everything runs on communication networks, right? It is almost all the important things, almost every critical service that we use, which is why keeping them secure is so important. But as the technology is being becoming more advanced, it is evolving, cyber attacks are getting more sophisticated. Hackers are constantly finding new ways to exploit weakness in these networks to steal the data or mess with the operations. Here, the big problem is when there is an imbalance in the network traffic. That is, some parts of the network are super busy, while the others are barely used. This creates an opportunity for attackers to sneak into the quieter, less monitored parts. It is much like how the thieves would target neighborhoods with fewer security cameras. This kind of imbalance can be a huge security risk because it gives the hackers a chance to exploit those areas that aren't being watched as closely. To overcome all this, we do have some traditional methods. We do have traditional methods which are mostly relying on rule based or signature based methods that have tough time keeping up with the fast paced and constantly changing nature of the modern cyber threats. These older systems just can't adapt quickly enough when attackers change their tactics. So, this is why we need smarter, more flexible solutions that can not only detect these emerging threats but also respond to them effectively. If we don't address this problem, it puts the integrity and security of the communication networks at a serious risk, especially as types of attacks becoming more complicated and harder to predict. So, developing more advanced ideas is essential for staying ahead of potential threats and keeping networks secure. So, to overcome all these issues in this project, we are incorporating a hybrid approach, combining several advanced techniques to detect intrusions in the unbalanced network traffic. Here, we incorporate XGBoost model, which is great at handling structured data. This helps to process the traffic information. And we have incorporated LSTM, that is long short-term memory, because it is really good at understanding patterns over time, which is crucial for analyzing network traffic that changes constantly. On top of that, we also have incorporated mini VGGNet and AlexNet. Both of them are excellent at extracting important features from the data. This combination allows the system to spot even the smallest and most subtle intrusion patterns that could otherwise go unnoticed, making it more effective at identifying potential threats. And here, in network traffic data, rare attacks they are hard to spot because normal behavior it dominates the data. If we just train a system on this unbalanced data, it will focus mostly on the common patterns and miss those rare critical attacks. So to fix this, we balance the data during reprocessing. We are incorporating undersampling technique to balance the majority class. Moving on, we have incorporated random forest regressor for feature extraction purpose. This will help us to figure out which features in the data are the most important features. By focusing on these key features, the system can make more accurate predictions while also reducing the amount of unnecessary data processing, making it more efficient. To further improve the performance of the project, we have incorporated an ensemble method, that is voting classifier. This method combines the predictions from multiple individual models to create one final prediction. By doing this, the system becomes more robust and accurate. And we saw the highest accuracy achieved through this approach. And we have developed front end using Flash framework, allowing for user testing. And the front end also includes the user authentication mechanism, which adds an additional layer of security and ensures that access is personalized. This makes the system not only more efficient but also more user friendly and accessible. Moving on to the implementation of the project, we have followed the steps mentioned in the flow of work to implement this project. The first step is importing the packages. First, we import all the necessary libraries and packages required for data processing, model building, visualization, and front-end development. And in the next step, we begin by analyzing CIC IDS 2017 dataset to understand its structure, features, and types of data it contains. This helps us to decide how to proceed with the processing and modeling. Then the next step comes as data processing, where any repeated data entries are removed to ensure that dataset is clean and doesn't bias the model. And we remove irrelevant or unnecessary columns to focus on the most important, most features for intrusion detection. Then comes the visualization part. We visualize visual representations like graphs and charts are created to better understand the data distribution and patterns, helping us to identify trends and outliers. Then we encode categorical labels into numerical values, making them easier for model to interpret during training and prediction. After that, we separate features as x and the target variable as y, where x represents all the input variables and y is the label or the outcome that we are predicting. Then we do feature selection. We identify the most relevant features that contribute significantly to the model's prediction accuracy and discard the less useful ones. And here, in the next step, data sampling, that is DSSTE using k-means and KNN data sampling. Here, data sampling using DSSTE with a k-means and KNN involves clustering. The data with k-means and selecting the representative samples using KNN is used to balance and reduce the data set while preserving its structure. Then comes splitting the data. Here we split the data into training and testing sets. Training set is used to train the model and testing is used to evaluate the model. That is, validation set is used to evaluate the model. Then comes building part. Here we develop and prepare the model using the selected features. And then the model is initiated in this step. After that, we use the model that is initiated to train the training data, to understand, to learn the patterns and relationships, enabling it to make predictions on the unseen data. Then we evaluate them using accuracy, precision, recall, and FN score, and we compare them using graphs. Coming to the part of front-end, a web front-end interface is created using Flash framework, which will allow users to interact with the model through user-friendly interface with user registration and login functionality backed by SQLite database. Then in the front-end users, they will be able to give inputs as feature values, that is network traffic characteristics, through the front-end interface. And that input will be pre-processed at the backend in the same way as the training data, ensuring it is correct format for the models to make predictions. And that will be feeded with the trained model. So the trained model is used to process the pre-processed input data and make predictions based on the user input. Finally, the result of the prediction is displayed in the front end, providing users with the outcome of intrusion detection process. So this is how we have implemented the project. And these are the algorithms used to classify the network intrusions. And this is the extension model. Coming to the requirements to implement this project, we need basic requirements that are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, hard disk of 25 GB, and software are application of Anaconda, primary language Python, front-end framework Flask, backend framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Here in the first folder, we have the dataset that is used in the project. So these are the different files in that dataset. After loading this data, after we concat them and after doing pre-processing in the coding part, then here is the processed file. This is the final processed. On this data only we will be training. After doing feature selection, after concatenating all the files, after extracting the features, these are the final features that are used to train the model for detection purpose. And here is the target column. Let's close this. And here in the static folder, we have files consisting CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And in this templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here is the app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have model file, which contain the algorithm information, and this will be loaded into the project code during runtime of the application. This is the notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here in this file, we have the test cases that we will be using in the front end to detect the intrusions. And this is the signup.db file. This file is a database file which is used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. Copy it. Now open the Anaconda prompt. Give the command cd, give the space and paste the copied path. And now click on enter. Here if you observe, current directory is changed to the code folders path. Now it's time for compiling app.py file. So give the command python space app.py. Now click on enter. So by giving this command, It will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So we have to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here. Click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? We're supposed to enter them to predict the network intrusion. So first we have is backward packet length mean. This refers to the average size of packets in the backward direction, that is from destination to the source over a certain period. It helps us to understand the generalize of the data being transmitted in the reverse direction. Coming to backward packet length standard deviation, this is the standard deviation of the packet size in the backward direction. It indicates how much the packet sizes deviate from the average size, helping to measure the variability of data transfer in the reverse direction. Then a forward IAT total, that is the FWD refers to the forward, IAT refers to the inter-arrival time, and this parameter represents the total time difference between the arrival of consecutive packets in the forward direction, that is from source to destination during a session or connection. Then we have is the forward IAT mean. This means the average inter-arrival time of packets in the forward direction. It tells us how long on average it takes for each packet to arrive after the previous one in the forward direction. Then forward IET min. This is the minimum inter-arrival time of packets in the forward direction, showing the shortest time gap between two consecutive packets sent from the source to destination. Then forward IET ST. STD, that is nothing but standard deviation of the inter-arrival time in the forward direction. It measures how much the time between packet arrivals fluctuates in the forward direction, helping us to identify unusual patterns in the data transmission. Then we have backward packets. This parameter indicates the rate of packets being sent in the backward direction, that is from destination to source per second. A higher value suggests more frequent data exchange from the destination to the source. Coming to average packet size, it is the average size of packets transmitted during the network session. It helps us to understand the overall size of the data packets in the both directions. Coming to average backward segment size, this is the average size of data segments in the backward direction. It gives insights into how much data is being transferred in each packet when going from destination to source. The last parameter which we have is the subflow backward packets. This refers to the total number of packets that are part of backward data flow in subflow. A subflow is a smaller flow data within the main flow, and this parameter measures the packets involved in the reverse direction from the specific subflow. So this is all about the parameters. Now we need to enter them. So for entering these parameters, we need to open the test cases that we have in the sample file. Let's open it. So these are the different test cases that we are using in this project to detect the intrusions. We have total 7 different classes that are being detected, that are total 7 different intrusions. So let's apply filter. Let's apply filter to class 0 and click on OK. And here, let's enter the first test case. Here, backward packet length mean it is 601.8. And the next one we have is the backward packet length standard deviation. So let's enter it. And then we have is the forward IET total, paste it. And then we have forward IET mean, paste it. And forward IET min. And then we have is the backward IET standard deviation. And then we have backward packets, that is 1.06. Average packets, that is 278. Average segment size is 601.8. And then we have is the subflow packet, backward packet bytes that are 5. Click on predict. So the given input will be pre-processed the packet and then we will be getting the prediction. Here we got the prediction that there is no attack detected. It is benign case. That means there is no attack for the given information. Now let's try predicting the other class label. So let's try with the class 1. Here 0 refers to benign case. That is why we got the prediction that it is benign. Now click on OK. And here let's enter all the values. So the first two values, that is backward packet length and mean and standard deviation is 0. And I forward IT total is 245, mean is also 245, and min is also 245, and standard deviation is 0. The next value we have is the packets, that is 4081.6326, and average packet size is 9.333, and the average backward segment size is 0. Subflow bytes are 1. Now click on predict. So for the given input, here we got the prediction that boat attack. So here attack is detected and that attack type is boat attack. Here class 1 refers to the boat attack. Now let's apply filter to the class 2 and enter the values. So let's enter the first case. Click on prediction. So the backward length mean and standard deviation is 0. The next value is forward IAT total, forward IAT mean, and the next one is min, that is 895. Then the next value we have is the 0. So give the value 0. And the next value is 0. Here we have entered it as O. Give it 0. And then here average packet size is, sorry, it is backward packet size is this one. So copy it, paste it. And here the next values are 0, 0, and 1. Click on predict. Here we got the prediction that attack is detected and that attack type is brute force attack. So here brute force attack has been detected. Now let's check with the class 3. So now let's try with this case, the first case. Click on prediction. 0, 0. The next value is forward IET1, that is forward IET total, forward IET mean. The next value is 1, that is forward IET min is 1. 0 is the forward, that is backward IET total. So here we have entered something wrong. Just wait. So the first two values are 0. Then the next one, forward IT total, we have is the 3,82,000 change. And the forward IT mean is this one. And the one is the forward IT mean. And here, forward IT standard deviation is, actually we have entered it correctly. Only here is the mistake that we have. So here it is 0. And then backward packet size is 0. Average packet size is 0. And then next we have a Z 7.5 as average backward segment size. And the last value is 0. Click on predict. And here we got the prediction that attack is detected. It is port scan attack. So here port scan attack has been detected. Now let's check with the class 4. So let's try with this case. Click on prediction. Here the first two values are 0. And the next value is 3752. Then forward IT mean is 750.4. Then IT min is 2. And the next four values are 0. And the last value is also 0. Click on predict. Here we got the prediction that attack is detected and that attack is DOS attack. So here DOS attack has been detected. Now let's check with the class 5. So let's try with this case. Click on prediction. Here the first two values, that is backward packet length mean and standard deviation are 0 and 960, that is forward total length is 960, forward IAT total is 480, and the next one is forward IAT mean is 1, standard deviation is 0. The next one is 141.6, and the next one is, and the next values are zeros, and the last one is 1. Click on predict. So here we got the prediction that attack is detected. It is port scan attack. So here port scan attack has been detected. Now let's check with the last class. Click on OK. So here, let's try with the first one only. Click on prediction. So the first two values are 0. And the forward IAT total is 5,64,000. Sorry, it is 5,64,000 only, and then paste it. And the min is 844. Forward ID is 0. Backward packet is this one, that is 0.19. And then next we have is the 0 and 1. Click on predict. So here we got the prediction that attack is detected. It is web attack. So web attack has been detected. Now let's check with the graphs. Click on graph. Here, the first graph which we have is the sample outcome graph. This shows the distribution of the classes that we are detecting in this project. Here on x-axis, we have all the class labels that are all the different types of attacks, and on y-axis, we have the count. Here, if you observe, benign case count is more than all other attacks. Benign refers to the no attack case. So no attack count is more. That is why we have used undersampling technique to reduce this majority class. And here, this is the correlation matrix. This shows the correlation between variables. And this is the accuracy comparison graph. Here on x-axis, we have accuracy score, and on y-axis, we have all the algorithm names that are used to train the model to classify the intrusions. And this is the precision score. Here we have recall score. Here we have FN score. Among all the graphs, if you observe, voting classifier has the highest metric, highest performance compared to all the other models. Now click on sign out. In this way, just by entering the parameters, that is required parameters, then we will be getting the prediction whether there is attack or not. If there is attack, it is detecting which type of attack it is. It may be port scan, it may be web attack, it may be DDoS, or any other type of attack that we are detecting in this project. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.